The Paleolithic era and the Pleistocene epoch, both of which concluded approximately 12,000 years ago, shared a significant historical overlap, despite their different starting times. The Pleistocene commenced around 2.6 million years ago, roughly 700,000 years after the Paleolithic era began. This epoch was marked by profound changes in geography and climate that had a profound impact on human societies. During the preceding Pliocene period, continents continued to shift, moving closer to their current positions from distances of up to 250 kilometers, 160 miles. One notable development was the connection of South America to North America via the Isthmus of Panama, which brought about a significant change in South America's unique marsupial wildlife. This isthmus formation had far-reaching consequences, as it disrupted warm equatorial ocean currents and led to cooler temperatures in the now isolated Atlantic Ocean, altering global climate patterns. Most of Central America emerged during the Pliocene, creating a land bridge between North and South America, enabling fauna to migrate between these continents. The collision of Africa with Asia resulted in the formation of the Mediterranean Sea, effectively isolating remnants of the Tethys Ocean. By the Pleistocene, the continents had assumed positions similar to their modern configuration, with tectonic plates separating from each other by no more than 100 kilometers (62 miles) since the epoch's inception. The climate during the Pliocene gradually became cooler and more arid, resembling modern climatic patterns. Ice sheets began to form in Antarctica, with evidence of the Arctic ice cap emerging around 3 million years ago, marked by shifts in oxygen isotope ratios and ice-rafted cobbles in North Atlantic and North Pacific Ocean sediments. Mid-latitude glaciation likely commenced before the Pliocene's conclusion, potentially contributing to the disappearance of forests and the proliferation of grasslands and savannas. The Pleistocene's climate was characterized by repetitive glacial cycles, during which continental glaciers advanced as far as the 40th parallel in some regions. Four significant glacial events were identified, separated by interglacial periods. During glacial epochs, these massive ice sheets, up to 1,500 to 3,000 m, 4,900 to 9,800 feet deep, locked up substantial volumes of water, resulting in temporary drops in sea levels by 100 meters, 330 feet, or more worldwide. Interglacial periods, such as the present era, witnessed submerged coastlines due to isostatic or other emergent motions in certain regions. The impact of glaciation was global, with Antarctica remaining ice-covered throughout the Pleistocene and preceding Pliocene. The Patagonian ice cap covered the southern Andes, while glaciers existed in regions like New Zealand, Tasmania, Mount Kenya, Mount Kilimanjaro, and the Rwenzori Range in Africa. The Northern Hemisphere experienced widespread glacier coverage, including the Cordilleran ice sheet in North America, the Laurentide covering the eastern region, and the Fennoscandian ice sheet in Northern Europe, including Great Britain. Additionally, Siberia and the Arctic shelf featured scattered ice domes, and the northern seas were frozen. The Beringia land bridge connecting Asia and North America was blocked by ice around 18,000 BP, possibly preventing early Paleo-Indians, like the Clovis culture, from migrating to the Americas. According to Mark Lemus, who analyzed collected data, the Pleistocene's overall climate resembled a continuous El Niño pattern, characterized by weakened or eastward-heading trade winds in the South Pacific, rising warm air near Peru, and the spread of warm water from the West Pacific and the Indian Ocean to the East Pacific, along with other El Niño indicators. The Paleolithic era is often considered to have ended with the conclusion of the Ice Age, when Earth's climate transitioned to a warmer state. This climatic shift may have played a role in the extinction of Pleistocene megafauna, although other factors such as disease and human overhunting are also considered contributing factors. Recent research suggests that the woolly mammoth's extinction may have resulted from a combination of climatic changes and human hunting. Climate change during the end of the Pleistocene reduced mammoth habitat, making it easier for Paleolithic humans to access these previously frozen areas. Small populations of woolly mammoths survived on isolated Arctic islands until around 3700 BP and 1700 BP, respectively, coinciding with the arrival of prehistoric humans on Wrangel Island. St. Paul Island showed no evidence of prehistoric human presence, though early human settlements dating back to 6500 BP were discovered on nearby Aleutian Islands.